Hi, my name is Garrett Wilson. I'm currently a senior at Columbia University, graduating in 2025 in a dual degree with Sciences Po Paris, and at Columbia, I study economics.
Hi, I'm a Master of Science student in computational and data-driven in civil engineering and data science here at Columbia University. And during our project, we worked with our teammates, Antonis Lyras, Matin Malekifar, and Karan Mutha.
So I want to set the stage for you. Let's go back to 2020. Imagine it's March 2020 and the entire world is shut down. We're all wearing masks, and if you brave the lockdowns to drive out on the open roads, you would see, especially in a city like New York or Los Angeles, you'd see there was no one out on the roads. It was a sigh of relief. And as a result of the travel restrictions and nobody being out and driving, going anywhere, we saw a drastic decrease in motor vehicle collisions on the roads. Another industry that was particularly affected by travel restrictions during COVID was the airline industry. And in our data, in looking to understand what have been the effects of COVID-19 on motor vehicle crashes, we also looked at the major airports in New York City, where we identified significant clustering of motor vehicle crashes to understand how air travel and motor vehicle travel have evolved since COVID, and notably the effect on all this on motor vehicle crashes. And so our goal is to look at this to try and understand what's happening, to provide insights and improve road safety and guide future transportation planning.
Thus, for these goals, we dived into data. And as we can see here, the heat maps are actually showing a clustering of crashes on major thoroughfares around JFK and LaGuardia airports, as expected. And especially knowing that high traffic areas, it was actually an industry that was very impacted during COVID. So around airports like the rest of New York, we saw this lasting fall of crashes since the pandemic in general, as we can see in the graphs in blue, but also a vivid decrease in 2020 in these numbers of crashes.
However, if we turn to passenger footfall at LaGuardia and JFK, New York's major airports, we see that the lasting decrease in crashes that we observe in the motor vehicle data is not the same with airline or with passenger air travel data. We can see that passenger air travel in both airports dropped to nearly zero in 2020 due to the pandemic and the restrictions. However, over the same period that motor vehicle crashes have decreased by 50% and 62% at JFK and around JFK and LaGuardia, respectively, air travel numbers have rebounded to either near 2019 levels, or in the case of LaGuardia, even exceeding it by about 4%. So we would expect that these two might be more correlated, but they're not. We can see that clearly motor vehicle crashes are experiencing an evolution of their own, and in this research, we wanted to attempt to figure out why.
So to figure out why and to find an explanation for these results, we dived into three different hypotheses. The first one was about maybe the rise in average prices of Uber, taxi, and Lyft fares to and from the airports that could have affected driving habits and crash frequencies around JFK and LaGuardia. The second hypothesis was about the percentage of passengers using bus and rail to reach the airports that has increased in the period of 2019 and 2023. The third hypothesis was the increase in popularity of advanced driver assistance systems in new vehicles that could have contributed to a decrease in those crash frequencies.
So if we turn to our first hypothesis that the prices of Ubers, taxis, and Lyfts played a role in decreasing crashes by encouraging people to use private car travel less to the airports, we took data on these average prices both to and from JFK and LaGuardia from 2019 to 2023 and regressed this monthly data against the monthly against the monthly number of motor vehicle crashes. And what we see is that if we look at the graphs, we can see a strong correlation as both crashes and prices dropped during the pandemic. However, as prices have consistently risen in the inflationary period following 2020, motor vehicle crashes have stayed consistently lower than they were at their pre-pandemic levels. We see from the regression outputs a significant effect of travel to and from JFK, a significant effect of 0.7 less crashes per dollar increase on price on average. And in LaGuardia, we can see some smaller effects both in Lyft pricing and taxi pricing. However, all these effects appear to be relatively minimal, and the significance of them is not uniform across the board. So there's likely significant omitted variable bias in our statistical testing. However, these results are nonetheless interesting. If we turn to hypothesis 2, this seemed initially to be a plausible hypothesis. However, the data has shown us that passenger use of the air train at JFK, which is the public transit that we had the data available for, has not actually has not gone back to its pre-pandemic levels in 2023. So we see that the use of passenger use of public transit to access the airports has actually remained quite a bit lower than it was pre-pandemic, even if it's higher than in 2019. So we don't see really any correlation with the decline in motor vehicle crashes. Finally, turning to our third hypothesis, we plotted data on ADAS adoption, market penetration of ADAS systems against the evolution in crashes. So this, we can see that the black line here is the annual crash frequency, and we see a clear negative correlation between crashes over here and the percentage of ADAS systems in motor vehicles. However, the ADAS technology adoption has risen significantly since 2019. However, with only 5 years of data, and this ADAS market penetration data is annualized, it's difficult to run any significant statistical test on this. Furthermore, the average age of cars on the road is 12 years old, so it likely takes some time for the effects of ADAS penetration to really show up. However, we can nonetheless see some visual correlation here that certainly suggests the need for more research into the effect of ADAS technology on motor vehicle crashes.
Therefore, our research suggests that driver assistance systems in vehicles have likely contributed to a reduction in crashes in New York, while fluctuations in taxi and rideshare pricing to and from the airport may have had a minor impact too. But however, public transportation usage has shown little overall change, indicating the need for further research to better understand the relationship between taxi pricing, crash rates, and air passenger behavior. Based on our findings, we recommend expanding the adoption of advanced driver assistance systems in vehicles, and particularly in taxi and limousine commissions, vehicles, and taxi share rides to enhance road safety.
Thank you very much.